today we are going to solve very simple numerical problem related to simple machine, and especially we are going to solve the numerical problem related to MA, VR, work input, work output and efficiency. This is very simple numerical problem. Let's start. Using an effort of 30 Newton, a load of 60 Newton is raised in a simple machine. These are the informations. If the effort is applied to a distance of 1.5 meter and load is raised to a height of 0.5 meter, calculate the following. Here some informations are given and the question is not complete. We have to calculate work input, work output, mechanical advantage, velocity ratio and efficiency. First we have to write the information given in the numerical problem, and I am writing this information. Look at this. First effort is given and then load is given. We are writing this. Effort E is equal to 30 Newton, load L is equal to 60 Newton, and remaining information is 1.5 meter. This is the distance covered by effort, and that's why this is effort distance, and 0.5 meter is the distance covered by load. That's why I'm writing this also. Effort distance ED equal to 1.5 meter, load distance LD equal to 0.5 meter. These symbols are very important because we are using this symbol in numerical problem. Okay, now we are starting with the first question. First is work input. What is work input? Now for work input we have formula. What? Work input equal to effort times effort distance, and we have to take the value. Effort is 30 Newton, effort distance is 1.5 meter, and when we multiply these two we'll get 45 joule. This is work input, work done on the machine. Now second question is work output. How to calculate work output? We have to write first formula. We have work output is equal to load into load distance, and it is given here. Load is 60 Newton and load distance is 0.5 meter, so I am writing this, and when we multiply this two we'll get 30 joule. Work output, it means work done by the machine is less, 30 joule, but work done on the machine is more, that is 45 joule. Okay, now next question is mechanical advantage. Now what is mechanical advantage? Mechanical advantage is load by effort. That's why I'm writing symbolically L by E. Here we have load 60 Newton and effort 30 Newton. Writing this value, if we divide 60 by 30 we'll get 2. Mechanical advantage 2. It means this machine magnifies the effort by 2 times. If we have to raise 200 Newton load, then 100 Newton effort is required to raise 200 Newton load. Okay, next, velocity ratio. What is velocity ratio? We have this formula. Velocity ratio is equal to effort distance upon load distance, and these two are given here, effort distance and load distance, and we have to write this value. 1.5 is if divided by 0.5, then we'll have what? 3. What it means? Velocity ratio 3 means effort covers 3 times greater distance than that of the load. Okay, now last one is efficiency. What is efficiency? We know that efficiency is equal to work output by work input into 100%. Instead of this formula we can use another formula also, mechanical advantage upon velocity ratio into 100%. Any one of them can be used. Okay, at this time I am using work output by work input. That's why work output is 30 joule, and that's why I'm writing 30 joule, and work input is 45 joule, and efficiency is always expressed in percentage. That's why multiplied by 100%. If we multiply and divide all this, then we'll get 66.67%. This is very simple numerical problem related to simple machine, and all the 5 terms which frequently comes in simple machine: work input, work output, mechanical advantage, velocity ratio and efficiency are calculated in this numerical problem. Okay, let's finish the class.